Hi guys! So today I'm going to show you how to code a neural network to detect digits using Keras and Python from the mnist dataset. Alright, so we're just first going to search what's the mnist dataset. Basically, the mnist dataset, it's a collection of numbers that were labeled, and it's basically 28 by 28 grayscale images of numbers. And our task is to classify them by using a neural network in Keras. So we first have to make sure we have conda installed on our system or Python. So to verify that, we can do python -- version. So for me, I am on Linux, so the default version of Python is 2.7. So I prefer to use conda so that I can use managed environments. And what I do is that I do conda activate, and now you see that I have my own Python 3.8 that's up to date. So I'm just going to start my tmux session so that I can edit code, and I will go and create a new directory. We can see in the directory that we're just going to start by making a Python file, and for now we're just going to say print hello world as every task we should do. So we go back, youtube-mnist, and I say python main.py, and I get hello world, so my Python installation is working fine. If you're on Windows, it's even more simple. It's not that simple, but it's pretty simple. You have to go on Anaconda, and when you search for Anaconda, you'll see that there is a getting started, and we see that that's not Anaconda. We want Conda for Windows, and we see that there's a whole documentation to how to install on Windows. So there's a mini conda installer for Windows, as well as a Anaconda installer for Windows. I prefer to use mini conda because it's smaller and it takes less space, but it doesn't really matter. So you follow these instructions, and if you need any help, you can just ask me later. So continuing on, we're going to import Keras. So we're going to say from keras.datasets import mnist. And we're also going to import matplotlib, which is a library that allows us to plot images. So I say import matplotlib.pyplot as plt. So just to verify that I have all my packages installed, I can run them, and you'll see that nothing is installed. So what I like about Keras is that you can create environments, and an environment basically allows you to use library code and to separate it into different environments. So I can have installed sklearn, Keras, as well as TensorFlow on one, and then for web development, I can only install Flask and no need for that fancy machine learning libraries. So I can create a new environment by using conda create-n and the name of my environment. So I'm going to create it using, let's name it mnist recognition. And so you say yes, and you can go to that environment by saying conda activate this environment. Now you see that I am in this environment, and I can now say that I want to install Keras and Python as well as so on, everything. So I'll do conda install Python, and I have to verify because now there's a new update. So 3.9 doesn't work with Keras, so you have to make sure that you install Python 3.8. And if you verify, here you'll see that Python is 3.8.5, which is what we want. And we're just going to wait, and we'll see that now we also have Python installed. So Python 3.8.5. Now we're going to install Keras, but if you are using a GPU such as an nvidia GPU, which I am using right now, as you can see, an nvidia GeForce RTX 2060, you'll have to install tensorflow-gpu before. So you can do conda install tensorflow-gpu. And technically it should work. Who knows? Let's see. And we now see that I have all this to install just to have TensorFlow-gpu, but we'll accept this because we need it. And so you can wait and wait and wait and wait and wait and wait and wait. So now that it's installed, we can verify that it installed by typing Python and say import TensorFlow. And as you can see, there's no error. No error means everything's running fine, so we're good. So now I can install Keras, which is basically a library on top of TensorFlow that allows us to make it easier for me and for everyone else to write models. So conda install Keras. And enter again, then you wait and you wait. Now, if I go to mnist, if I go here, I have to exit my editor and say conda activate, what was it called? mnist recognition. So I can now rename this pane on tmux with code and this pane with shell testing for testing purposes. And now I want to make sure that my file can be run. And I forgot to install matplotlib, so I have to install it. So I say conda install matplotlib. And you wait again as expected. Enter. And you wait. And you'll see that now when we execute it, nothing happens, which is great sign. So there's no error, everything's working, hallelujah. And we can now start and get into the real deal. So I like to use IPython just for experimental purposes. So you can install it by using conda install IPython. And if it doesn't exist, you can use pip in the worst case. And I do remember that it didn't work. So everything was working. Ignore what I just said. And I can now run IPython. So I say IPython. And I can import Keras. And from Keras, I can import the dataset. And the dataset that I want specifically is the mnist one. And as you can see, everything runs correctly. And if I say mnist.load data, I've already looked at it and I know that it's in the format of xtrain, ytrain, xtest, ytest, and that's equal to mnist.load data. So basically, if you understand the syntax, it means that mnist.load data returns a pair of objects, and each pair represents an x and a y, and the first pair represents the x train and the y train, and the second pair represents x test and y test. So we can analyze the shape of what it looks like by saying xtrain.shape. And you can see that I have 60,000 samples of 28 by 28 images. And for example, if I want to show one, I can say import matplotlib.pyplot as plt, and then I can say plt.imshow for image show xtrain, and I show the first one. And I have to make sure that it's grayscale, so I put color map cmap equal gray. And then nothing's going to happen, that's expected. And you have to make sure that you run plt.show to make it run. And now we see you have a beautiful number 5. To see if it's really number 5, you can go to ytrain and say, what's the first element? And you can see that it was 5. So everything's working well. So I can now exit this and add it to our file. So we're going to load the data. So I'm going to create a function just to load the data. And I can do mnist.load data. And we know that it's in the format of xtrain, ytrain, xtest, ytest, and this is equal to mnist.load data. If you continue, you'll see that maybe we can just show the images. So we can say show images xtrain, and we'll say that we want it in a 5x5 grid. Show images does not exist for now. We have to create it. So we'll create our function, define show images. It'll take some images and a layout. And I'll say by default it's, 3x3. And now I have to make sure that my images can be shown. So I have to go, how many images in total do I have to show? It's the area of layout. So I say total equal layout 0 times layout 1. That's basically the area. So I can now say for I in range total, I want to put it into subplots. So the first one goes here, the second one goes here, the third one goes here, the fourth one, and so on, so on, so on. So I say plt.subplot, and now I just say the dimension. So it was layout 0, layout 1, and then which one, which index is it at? So it is at index I plus 1 instead, because the subplots have to be numbered from 1 and so on, not unlike any other thing that's indexed from 0, which is kind of sad, but who cares? So we're now on our subplot, and now we have to add the content to this subplot. So we can say plt.imshow, as we saw, images I, and I can say cmap equal gray, and I can also put a title to it. So I can say plt.title hello. I can then say plt no, and now I think it should work, and let's hope it works. So we have load data. Now if I just run this, I'll get nothing. And I think I forgot to invoke plt.show. And now we see I invoked plt.show, and we can see all of our data set. And now I'm going to replace the title not by hello, but by the number it means, just to see that there's no weird thing going on and that our labels are misplaced. So I'm going to adapt show images by also adding titles. And I'm just going to say its title is going to be hello. And there's a cool thing called f-strings in Python, which allows you to put an f in front of the string, and you put curly braces to put the variable inside. So titles, and I want to index I. And now it should work again. And we see 55004411992211331144, and so on. now we have to create our model. Oh, I'm kind of tired, gonna take a break. Alright. So we've managed to show our images as well as their labels, and we've noticed that everything matches correctly. Now it's time to do some pre-processing. Pre-processing in machine learning is basically adapting your data so that it's more easier for your models to digest. So for example, and the neural networks all prefer values that are not from 0 to 255, but rather from 0 to 1. So to scale it, I can just say that this is actually raw x-train and this is actually raw x-test, and I can say that x-train is actually raw x-train, and I want to make it over 255 because the pixel values range from 0 to 255. I want to make it from 0 to 1, so I divide by 255. And this is not going to work out of the box because raw x-train contains integer, which are entire numbers, and when you perform division on it, it's not going to keep the remainder, the decimal part. So we have to cast it to a float, so decimals. So the as type float 32 over 255. And we also have x-test equal raw x-test dot as type float 32 over 255. And I'm just going to return x-train and x-test for now. And I run it. One thing that's really cool is if you want to see what's happening after, you can say ipython-i for interactive mode main.py. And nope, I don't want to correct it. Sorry, ZSH. And we see that we get our images, and that now I can inspect. So xtrain.min, what is its minimum? 0. Max 1. So everything's working well because our values are now scaled between 0 and 1. So that's going to be it for now. I don't want to bore you with a lot of details. So the next video I'm going to make is that we're now going to pre-process the labels, the answers, the labels. And we're going to create a model and so on. So if you like this content, you can subscribe and like and all that good stuff. So thanks a lot.